Today, let's look at an antenna that's liked by many hams, the magnetic loop. However, we won't look at it in the usual way. That is, we won't talk about how it works, what its features are, or even how to build one. Instead, we'll investigate how to optimize a magnetic loop. As this sampling of magnetic loops from the internet illustrates, the mag loop as a homebrew project and as a commercially built antenna is very popular, and that's not surprising. It has some unique properties and is easy to build from hardware store materials. For hams with limited space, for portable operation, or as a receiving antenna for noise canceling, it has much to offer. But unfortunately, despite the large number of magloop websites and popular designs, good solid principles on how to optimize a magloop are at best hard to find. Guess and golly is much more the rule. It is little wonder then that many who follow these guidelines are less than satisfied. Part of the problem is that hams don't often think much about optimizing their antennas, except perhaps for SWR. Take a basic dipole. What else does one optimize it for, except to the lowest SWR, by adjusting it to the optimum length with the classical formula or an antenna analyzer? But for a mag loop, there are quite a few more optimization steps. And because many mag loop builders and buyers don't realize this, they end up disappointed. Mag loop optimization is not difficult, but knowing how and when to perform all the steps is essential if one is to achieve the performance they expect from this remarkable little antenna. Conductor diameter compared to loop diameter is the first and most important optimization factor. It's the biggie. It's where most loop builders fail. Conductor loss or loop efficiency is the #1 concern with mag loops. It's not nearly as important a concern for larger, more familiar ham antennas like Yagis, full-size verticals, or inverted Vs. Conductor loss also sets the lowest frequency usable for a mag loop. Yes, even though many websites don't mention it, and sometimes even provide oversized tuning capacitors to let you tune below the limit, mag loops have a low frequency limit, and this limit is determined by the diameter of the loop's conductors. If the loop's conductors are too small, as they are on many loops, the loop has a very limited low frequency limit. This chart shows the importance of large diameter conductors for mag loops. The orange region is unacceptable loss. Note that even with heavy number 10 wire, operation only down to 15 meters is acceptable. By increasing the diameter to RG8 coax, which many websites suggest, the lower limit only moves down barely to 20 meters. 2-inch pipe just makes 40 meters. On 40, 3-inch pipe would be better. The same relationship applies to all loop and pipe sizes. Mag loops must have big, fat conductors. For a quick visual tool to evaluate all magnetic loop antennas in respect to conductor size, capture with your mental camera an image of the next slide. It is what a magnetic loop with a minimum size optimized conductor looks like. they could be larger. For good efficiency on HF, an optimized magnetic loop needs a minimum loop-to-conductor diameter ratio of less than 24:1. That is, if it does not look as husky as this 4-foot loop with 2-inch conductors, it is not optimized. With these proportions, it will have better than 50% efficiency from 10 meters down to a reasonable low-frequency limit. Here's a commercial mag loop that meets the requirements. We will see it again later when we look at the upper frequency limit of mag loops. The second mag loop optimization factor, the material from which one builds the loop, offers considerable cost benefits, particularly for the home builder. This optimization is caused by skin effect. As many hams know, skin effect is the tendency of alternating or radio frequency current, illustrated here in red, to run only on the surface of conductor, here solid aluminum wire. In the center, there is essentially no current. Said another way, the center of the conductor isn't needed. For making magnetic loops, we take advantage of this by replacing the expensive, heavy, solid metal pipes commonly used to build magnetic loops with inexpensive, lightweight PVC-covered pipe with a thin layer of inexpensive, self-adhesive metal foil tape. Here is skin depth in thousandths of an inch, mils, in aluminum and copper on the ham bands from 80 meters to 70 centimeters. A thin layer of foil tape is just as good as solid metal pipe and is equally good at handling power, provided the surface area is the same. For example, a strip of 1 inch wide 1.5 mil aluminum tape will carry as much RF current as 3/8 inch aluminum tubing. Self-adhesive aluminum foil tape on PVC pipe is the Optimum magnetic loop conductor material. It is readily available in widths from 1/4 inch to several inches and in thicknesses from 1.5 to several mils on the internet. Local hardware stores also carry it for use on air conditioning ducts. Some may think it better to use copper tape. Copper tape is also suitable, but it is no better for building magnetic loops. Yes, it is more conductive, but its skin depth is less, and it is more expensive. For cost comparison, here is a recent price check on 10-foot lengths of 1 1/2 inch copper and PVC pipe. The outside diameter is 1.9 inches. You need 2 lengths to build a 4-foot square loop. Aluminum is not as bad, but is still roughly half the price of copper. The third mag loop optimization factor, loop shape, might seem like a personal choice. Not so. As an optimization, when it comes to ease of construction, neighbor appeal, and homeowners association approval, for the scowling face looking over the fence, the shape of your loop may be the most important optimization of all. A round or an octagonal shape for a mag loop got stuck in ham thinking in March 1968 in a QST article by Lou McCoy on the Army loop, developed for use in Vietnam by Ken Patterson. But for 2 good reasons, neither octagonal or round are optimal. In the 19th century, when Michael Faraday, the great radio pioneer, was investigating magnetic loops, he discovered that only the area of a magnetic loop matters, not its shape. As long as it has the same area, a square loop works the same. But for building magnetic loops, a square is much easier to construct in a home workshop. Also, of the three equal area loops seen here, the square loop is only 6 inches larger at the corners. That's trivial. Square clearly is the optimal shape for a ham magnetic loop. Further, nosy neighbors and homeowners associations notice strange shapes. They are far more likely to ignore a square loop, presuming it's probably just a rose trellis. With some plastic roses, it could even be one. Even a few real flowers probably wouldn't matter very much. The fourth optimization factor, one that's also little known to many loop owners and builders, is loop self-resonance. Similar to the lower frequency limit, mag loops also have an upper frequency limit, which is rigidly set by self-resonance. Not knowing it during design or when purchasing a loop can also lead to disappointment. Any conductive object, such as this plain loop, possesses natural inductance and capacitance. These combine to make the object resonant, or better said, self-resonant. The larger the object, the lower the self-resonant frequency. To see self-resonance in action, just disconnect the tuning capacitor from a mag loop and sweep it with an antenna analyzer, and you will be able to measure the dip at the natural self-resonant frequency. What's important about self-resonance is that a mag loop can't operate above its self-resonant frequency. You can't make a mag loop tune higher by adding more inductance or capacitance. For example, a 2-foot square Optimum mag loop can work up to 70 megahertz. A 4-foot loop can tune up only to 35 megahertz. The limit for larger loops is proportionately less. This earlier example, a 6.5-foot loop, has self-resonance just above 20 meters, so it won't work above 20 meters. Having now seen both the high and the low frequency limits of a magnetic loop, it is clear that no one single loop is good across the entire HF spectrum, despite what many websites claim. Prospective builders and buyers should optimize their choices for their specific needs. Be cautious of unrealistic claims. Let's now look at an optimized example. Here is a sample optimized foil and PVC mag loop that I'm currently still working on. It is not a complete step-by-step cookbook project yet, complete with details and dimensions. I show it here for your innovation. Several, though, have been successfully built from what you see here and have made contacts around the world. Here is the layout. 4 42.5-inch foil tape covered PVC pipes, 3 vertically cut elbows, and a T, internally foil tape covered, a 2-inch PVC mast, and a 2-inch T cut in half horizontally to act as a saddle. The top PVC pipe has an 1.5-inch gap in the outside foil. We will examine the feed and matching assembly later. Because it can be tricky, here is my approach to applying the aluminum tape. Cut a strip 6 inches longer than the pipe section. Remove a 1-inch tab of the backing at both ends. Fold the tabs over and stick the strip backing upward to a flat surface. Carpet is best. Remove the remaining backing and then push the PVC pipe carefully onto the tape. Snip off the tabs and then roll the PVC pipe on the tape. Smooth out the wrinkles with a short piece of PVC pipe. Trim the pipe ends. The corner elbows are cut in half vertically on a bandsaw or with a hacksaw, and the foil tape is applied inside. With a little practice, the application seen here can be achieved. Be sure the surfaces that mate with the foil-covered pipes are rubbed smooth with a length of small PVC pipe. Possibly one of the least optimized aspects of most homebrew designs is the matching assembly. There is probably not one best design, and several work well, but two factors stand out as optimal: ruggedness and simplicity of construction and adjustment. These two commonly seen methods are electrically optimum, but are examples of matching assembly that are either not mechanically sound or are difficult to build and adjust. This 3-section aluminum tubing RF auto transformer tap match assembly is, however, robust, and adjusting the area between it and the loop easily achieves a low SWR with the loop mounted in any position. Precise dimensions are not critical. Use a strip of foil tape to connect the body of the SO239 socket to the through mounting bolt on the loop, and with a short piece of solid wire to connect to the center pin of the first bolt on the tap assembly. The final optimization factor, loop tuning, is primarily a matter of cost, operational convenience, and user innovation. Hence, for this presentation, it is still in development. A vacuum variable or wide-space rotary variable capacitor may of course be used to tune the loop. They are optimized choices in respect to convenience, but neither is cost optimized. Further, rotary capacitors require weatherproofing and often have internal losses. Here is W7QHH's 4-foot foil and PVC loop in construction using a rotary capacitor. For this presentation, I sought something far less expensive to elicit enterprise. It is an internal linear capacitor adjusted simply by pull cords. It is of course manual and does require a fine touch during adjustment, but several loops using just this simple method have been built and have been used to make contacts around the world. Currently, I am exploring using dual tuning, a 1-inch N-foil covered internal tube for fine tuning and an exchangeable fixed position partially foil covered external half-round 2-inch PVC tubes for band change. Currently, my external tube is covered for 12 inches and the 20-meter half tube is covered for 14 inches. I do not yet have other band lengths. With experience, you may wish to adjust these lengths for finer adjustment. Here's how it works. Inside the loop, by straddling the outside foil gap with a smaller foil-covered movable PVC pipe section, also covered with foil. 2 capacitors in series are created across the gap. If the inside pipe is centered across the gap, the capacity is maximum. If it is off-centered, the capacity is less. This design is also weather protected and has a high voltage rating. Here is the 20-meter external band change capacitor section and the internal fine-tuning section. Again, the lengths can be adjusted with experience for finer control. The 1-inch PVC pipe with foil on the other end comes out through a hole in an end cap in the T at one top corner end. Make marks on the pipe to help in fine tuning. Once set close, final tuning can be done with only small loss with a tuner in the shack. Note the stainless hose clamp in place of sheet metal screws to allow for the sliding capacitor section to pass freely. Enterprising builders might want to investigate slotted computer printer belt or plastic lead screws and stepper motors to automate the adjustment. Send me photos if you do. And if you do build one of these loops, and especially if you innovate, send me photos and the results of your QSOs. I enjoy feedback. You may download this presentation from the QSO Today Expo website after the Expo, or as a PowerPoint presentation with narration from my website, W6NBC.com/magloop. To give you a few moments to make a record of this, let me give you a little plug. I will be happy to repeat this presentation in an expanded version in your local radio club, live by Zoom. Send me an email at jportune@aol.com or w6nbcmail@gmail.com. That's jportune@aol.com or w6nbc@gmail.com. This is my little Shih Tzu, Lolly. No, she does not have a German call sign. I just like to pretend.
I'm muted, weren't I? Ha ha ha. It's going to happen sometime. Thank you very much for that, John. That was a fantastic presentation on the optimizing the magnetic loop. I like that a lot. I've got your contact info up on the screen there. Can you make sure that I got your emails correct? Is w6nbcmail@gmail.com?
That is the best website. I mean, the best email contact for me. Yes.
Okay. So we've got your contact information on the screen there for everybody. Thank you for that. And if you have any questions, please type them into the Q&A. You won't see other people's questions, but we see all the questions. So go ahead and type up all the questions you've got there. We'll start out with one from Thomas. Thomas asks, I want to build a magnetic loop for 160-meter use only. Could I just add 2 loops of either a 4 or 6 foot square?
Yes, one can certainly use more than a single loop. Multiple loops work fine. They're in fact quite efficient. So I haven't done any work yet on multiple turn loops, but 2, 3, 4 foot turn loops are perfectly efficient. But as far as me giving you any practical advice about dimensions and so forth, but the same principles apply. Use good. If you build it 4 foot, use 2-inch diameter PVC and just make it multiple turn. You'll obviously have to make one turn slightly longer so you can cross over at the top to get from one end to the other end. But I started modeling a 4-turn loop
excuse me, and it looked good. So I'd be most happy to get some feedback from somebody who'd like to who'd like to try a 4-turn loop. It would
Yeah,
certainly be possible.
I've always wondered about that. What because they talk about, and you mentioned in your presentation that the surface area, the area inside your loop, is the important part, and that's why if you're going to use a certain amount of material, making it larger, you're going to get an R squared effect in your area there, but you also get the square of the inductance with multiple loops with a number of turns. And
You're
so I
right.
wasn't sure if the same amount of material in two loops versus one larger loop was one of them going to have a benefit over the other.
No, essentially the same. Two loops with twice the area is the same as a loop that's 1.414 times the diameter. So it's again the total
Yeah.
area involved. Two loops will have 1.414 times the square root of two times the amount of area, so it'll be that much more effective. No, multiple turn loops are definitely effective.
Huh, then why don't we see more of those? I wonder.
Well, if you search the internet, you'll occasionally run into them,
Okay.
but
All right.
but
Well, that's
remember, keep the conductor size up.
yes, absolutely. All right. Keith asks a question. ZS1HI asks, is it possible to use a worm gear excuse me, a worm gear arrangement to be able to move the inner capacitor tube in and out using a stepper motor? Thanks for the
Oh,
great presentation.
absolutely. Better known as a lead screw arrangement. Sure. Uh, a stepper motor off the end. Put that T connector at one end. Mount this stepper motor out at the end somehow. I haven't actually figured this out yet. Put the stepper motor at the end and drive a lead screw in to move that inner capacitor element. And you can make the inner capacitor element bigger if you want. With a lead screw, you should be able to get a fine adjustment uh, out of that.
Yeah. Steve, WB9YSD asks, do you have any corrosion issues at those joints? And if so, do you recommend any corrosion inhibitors?
Well, I don't have any practical information or, actually user information about it. But NOAA locks, the material that's often used for connecting aluminum joints together in beam antennas, might be a good idea at the joints. I wouldn't think that would be a bad idea at all because the joints connect mostly by capacitive coupling anyway. They don't connect too much by pure resistive coupling. So putting some NOAA locks on there, which has a conductive material in it, would be a good idea. But the coupling between the aluminum surfaces together is mostly by capacitor coupling, so they do make good contact that way.
John and I both live in California, in a very nice weather area of California. So we don't suffer the same kinds of corrosion and extreme weather situations that a lot of the rest of the world does.
But even a little plain silicon grease is a perfectly good idea between the surfaces. And believe me, a little silicon grease between it is not going to stop the conduction
No.
because again, it's by capacitive coupling that it happens.
Cool. James, AE5JD asks, what power level can you use with the foil covered PVC tuning capacitors?
Well, let me again emphasize the fact. Use a Socratic teaching method here, which is to answer a question with a
With a
question.
question. Yeah.
Yeah, it's a Socratic teaching question with Socrates, developed way back BC. Uh, uh, would you think that a piece of 3/8 inch aluminum tubing would handle power? Well, I think most of you would think you could probably build yourself a nice big kilowatt amplifier with a piece of 3/8 inch aluminum tubing. A 1 inch wide piece of 1.5 mil, that's 1.5 thousandths inch thick aluminum tape will handle the same amount of power. So have no fear with using foil tape to handle power. It's very good.
I think James's question had more to do with the actual tuning capacitor. As the power goes up in a magnetic loop, you get incredibly high voltages at
Oh,
that tuning
voltages,
capacitor.
sure. I did a little bit of a workup on the tuning capacitor, and in this particular tuning capacitor here, you get about 4,000 volts at a kilowatt. So, which is not great, and the thickness of the PVC in there, as far as I could with a quick scratch calculation, should tolerate it very easily.
Yeah, I would think the thickness, because it's not metal to metal with air in between. It's metal, then PVC, then metal. You've got that thickness of your PVC pipe as part of your dielectric, and so that's going to have an
And it
incredibly
goes
high
off in
voltage.
both directions away from the foil as well. So
Yeah,
it's good insulation.
yeah. Okay, Montgomery asks, VA7MMW, can you comment on the efficiency and practicality of loop designs using a folded or spiral loop construction rather than a single tube loop?
You mean spiraling around the plastic? Is that what he means?
I don't know. That's a good question.
Well, that's an idea that I see in a number of websites where people make a PVC loop and then they wind tape around it in a spiral with gaps between. Not a good idea.
Yeah,
Why? Because it reduces the conductivity of the it defeats the defeats the conductivity of the conductor. It defeats the number one weakness. So a spirally wound loop is not a good idea.
I would also expect that to add series inductance,
It
but in a
does.
toroidal way, in a way that you're not going to be able to get any outside magnetic fields into it.
Well, no, I don't know about that,
Yeah,
but it will greatly increase the inefficiency of the
yeah.
loop.
I'd like to hear some arguments on that one, but I
Yeah, I
can't think
would
of a
too.
reason why that would be a good idea.
It is not a good idea, believe me.
Yep. Randy N8NAZ asks, would you recommend using two separate loops for more efficient results across multiple bands?
Well, two separate. Yes, of course. If you want to cover the high end and the low end, you use a small loop for the high end and a big loop for the low end. Is that what you mean, or coupling them together at the same time? I'm not quite sure what you mean there.
I don't know either. I cannot imagine that coupling would work. If you have two separate loops, one for the high end and one for the low end, I think that's probably the best bet.
Well, you could certainly build two loops, smaller high frequency one for the top end a little 3 footer for 10 meters down through about maybe 20. In fact, I have one reader who's got a very nicely built 3 foot loop from 10 down to 20, and then another bigger loop that goes down to 80 meters. But I can easily imagine using a phasing network to couple the two of them together so that onto one coax, in other words, a diplexer, to
Yeah.
couple the two
Okay.
of them together. But if that's what he means, that would certainly work.
Arthur asks, is there a best diameter, in quotes, for 17 and 20 meters if I wanted to use it as a receive-only loop? W1SWL.
The 4 foot loop, the 4 foot square loop, is a really good compromise for middle HF. I find 4 or 5 foot, 3 to 5 feet is a good size for the middle of the HF band. 3 foot doesn't go down much below 20 meters. I would say if you want to hit 17, yeah, 3 foot loop will go down nicely to 17. So 3 or 4 foot loop is roughly a pretty decent sized loop,
Right.
and then you can use 2 inch diameter conductors though.
Perfect. Okay, another one from Montgomery, VA7MMW. Does the shape of the loop affect the radiation pattern?
No, No, the radiation pattern is pretty much similar to a basic dipole.
Yeah, but it's end on. It's not broadside.
Oh no, end on, yes.
Yeah, so that's important to mention. So if you think about the loop here, the radiation patterns are coming out the sides of the loop, not out the broadside of the loop.
No, no, it's not a broadside radiator. It's an end radiated loop. I haven't covered any of the theory of how the
Yep,
loop works. You'll find there's a lot. There's a lot on that on the internet if you look up the theory of the loop. But it's no. But the shape of the loop, whether it's square or octagonal or square, doesn't make any difference.
doesn't matter.
They radiate almost identically, as Faraday showed.
Yep. All right, I think we've kind of already seen this one a little bit. Eric, WA7WAL asks, how much power can this loop handle?
Oh, what the 4 foot square?
Yeah.
Full limit easily.
Yeah. Thomas says, great presentation. Thank you very much.
And remember, you can download it off my website, w6nbc.com/magloop. You can see the same presentation you just saw over and over and over and over again if you want to.
That's right. We got some more questions here. Let's see here. Ronald N6YWU asks, can a flat form for the tape be used instead of cylindrical?
Yeah, I suppose. I don't see any terribly good reason why you can't.
The skin effect starts pushing the energy out toward the edges of the tape, doesn't it?
Yeah, it does. Round is better because you get more you get a less skin effect loss with
More
round.
efficient use of your material.
Yes, you do.
Yeah. But if you've got like maybe, 4 or 6 inch strap and you have it laying around, you might as well use it.
Yeah. I don't recommend strap, but I recommend round, or
Yeah.
square, or
All right.
PVC is so easily available. That's why I recommend it.
So Art also asks, is there any power handling consideration for a transmit loop? Yeah, so we've already covered that one.
Yeah.
These should be able to handle full legal limit.
Oh yeah, no problem, no problem with a 4 foot square, even a 3 foot square handling full legal limit with. I usually use 4 mil tape. When you go on the internet looking for the aluminum tape, look also for its thickness. You'll easily find 4 mil thick tape on the internet. I usually buy 4 inch wide, 4 mil thick tape readily available on the internet, usually for about $15 a roll. It's not terribly expensive.
And so because the aluminum, it has a thicker skin depth, but that means that you're using more of the aluminum in parallel, so its higher resistance ends up coming out to be about the same as copper.
That's right. There's no advantage to copper, and aluminum's much cheaper,
Much cheaper.
and much more readily available because it's used for taping up air conditioning ducts.
Yeah.
And you can buy it at the local hardware store.
That's perfect. All right, Clyde, WB8HLS asks, designing a hidden horizontal loop hung from a garage rafters, 20 by 20 feet, to increase conductor diameter, would 4-inch wide metallic ribbon be practical?
Yes, but I don't recommend horizontal loops. You won't like the radiation pattern.
Well, at 20 by 20, this is no longer a magnetic loop.
Oh no, I'm sorry. No, I'm sorry.
Yeah.
Yeah.
So
no,
that's a different antenna than what we're talking about here.
Oh well, aluminum foil tape is a wonderful building material. It replaces wire or rod or tubing in almost any circumstance. So don't fear using foil tape. You stick it to walls. You can put it on the outside of your RV. It's a wonderful, versatile building material.
Forgive me, I'm not sure if this is Jamie or Jaime, but KD9RQF asks, have you compared the gamma match and the coupling loop match against each other?
If you can make a match an antenna, it's the powder and shot difference to blow it up. If you can get a 1-to-1 match, It doesn't matter
Doesn't
what
matter.
kind of a match
Yeah.
you loop. The little round separate coupling loop works fine. It was my favorite matching method till I discovered how easy it was to make one of those little 3-section tap matches. With all matching systems work the same as far as the antenna is concerned once you get it matched.
Is okay. Let's go look at this one again from Jamie or Jaime. Again, forgive me if I'm mispronouncing your name. Is the adhesive conductive on the aluminum tape? Is the adhesive conductive on the aluminum tape that you use? Oh, sorry. Okay. Is the adhesive on the aluminum tape that you used conductive? There we go. I would imagine it would have to be, right?
No, absolutely irrelevant. Or if you prefer, irrelevant. No, irrelevant.
And why is that again?
Because when you put two pieces together, two pieces of metal together like that, if there was a pure perfect insulator in between, would alternating current go through it?
Looks like a capacitor to me.
A capacitor.
Yep.
It doesn't care if there's a little bit of dielectric in between. RF goes right straight through it. Doesn't care that there's insulation on it.
All right. This is a long one. It's going to get chopped off on the screen, so I'm going to have to read it.
I think it's all. Go ahead.
Yeah. As always, great presentation, John. I reside in a strict HOA development and recently installed a Ciro Mazzani baby loop of 40 meter to 10 meter in the attic. Because of the structures in the attic, it is only a few feet above the attic floor on a rotator. The attic floor is 13 feet above earth ground. Would adding a ground screen improve the performance? So the question is, do these mag loops have to be over a ground? And if we mount it at ground level, are we using the earth ground for that? And if we elevate it, would it benefit to create an electrical ground closer to the antenna?
Let me just give you a simple answer. Mag loops and other antennas respond to grounds pretty much in the same way. So would a ground plane under a dipole help it? Yes. Will a ground plane under a mag loop help it? Yes. Well, where would you put it? Approximately in the same place. So the answer, there isn't a specific answer for the mag loop compared to some other antenna.
Got it. Okay. Let's see here. Gil W6NBC asks, does the aluminum tape wrap all the way around the tube, or does it overlap?
Yes. I know that's not the answer, is it? Yes, you have to. Most in a piece of 1.5-inch PVC, if you buy 4-inch wide aluminum tape, it won't make it quite all the way around. There'll be about that much gap. You've got to use two pieces. You got to put it on twice. So, okay. And as long as the tape is overlapped by about an inch, it is completely RF connected to itself, even despite the adhesive on the tape. So it takes two pieces of 4-inch wide tape to connect. By the way, if you build any antennas out of aluminum foil or copper foil tape, as long as you overlap the tape by about an inch, it is completely electrically connected despite the adhesive.
Gotcha. Marcus has got a good one here. Marcus N5ZY asks, in a multi-turn loop, do you calculate the distance between the two loops or just do what is practical for construction materials?
The latter. The distance between the turns is the same as the distance between the turns of a coil. They're like in a coil, though, there is some adjacent turn skin effect. So I would place the turns some distance apart. The ideal distance to place turns apart in a coil is a spacing of about 3 to 1. So if you're going to make a multi-turn mag loop, ideally, I think I would place the turns at about at least a 1-to-1 spacing ratio, which is sufficient. There might be a little adjacent turn loss in that. 2-to-1 would be better. 3-to-1 would be no adjacent turn loss. When you get two turns like this of a coil, and you bring them together, the RF tends to run away from the adjacent turn like that.
Yeah.
So, but if you move the turns apart, there is no effect of the adjacent turn. So yes, you want to move them apart by some
So
distance.
when you say 2-to-1, you mean if my conductor material is 1.5-inch pipe, then I want to have at least 3 inches between them. Is that correct? For a 2-to-1?
Yes.
Okay.
Yeah.
So two
I find
times
that
the space between them as the diameter itself is.
the generally reckoned, if you place the second conductor in any coil, loading coil on your HF rig on the car, if you place the second turn 3 diameters of the wire away, there's no adjacent turn
Gotcha.
loss. So, but I find that 1-to-1 the loss is fairly minor.
Okay. Ba, 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 ba. Okay, so I'm seeing a bunch of questions that we've already answered before. Safe operating power. How do you determine? Oh, this is a good one. How do you determine a safe operating distance?
Well, is this the famous RF exposure business?
That's my guess as well. Yeah.
Yeah. Well, I don't think it has any answer other than other antennas. Of
Yeah.
course, these antennas do have very intense magnetic fields right down the middle.
Yeah, as long as you're not sticking your pacemaker right in the middle of the thing.
I
suspect it's
stick your head in the middle.
Yeah, exactly. I suspect it's going to be the same as pretty much any other antenna.
Yeah, and I don't have the equipment or the experience or the knowledge or the data to answer the question.
Yeah. All right, Dick. AH6EZ asks, what is the SWR bandwidth with fixed tuning?
With fixed tuning, what does that mean?
I think you just if at a given tuning of the capacitor, what's the bandwidth?
Well, it depends on the loop size. It depends on the loop size.
Well, the point being that, like, assuming you don't go outside and move the capacitor, at any given one location of the tuning capacitor, how much bandwidth do you get out of that antenna before you have to go move the capacitor again?
Of that 4-foot square one? Is that what he wants? I think I have an SWR curve for that one.
I mean, the point is that magnetic loops are awfully darn narrow.
Yeah, they are narrow. If the questioner should send me an email, W6NBC.com, W6NBCmail@gmail.com, and I'll send you a bandwidth plot of that antenna. I don't have it off the top of my head. It's narrow, of course. All magnetic loops are narrow.
Yeah.
Are narrow bandwidth.
Oh. Okay. Michael WH6ZZ asks, how much radiation pattern change comes from more turns on a multi-turn loop?
I don't think a multi-turn loop has any difference of radiation pattern. That's my off the top of my head. I think they radiate the same as a single-turn loop.
That would be my guess as well. Jamie confirms that his name is pronounced Jamie, not Jaime. Thank you very much, Jamie. Kevin K5AZZ asks, the 4x4 loops, what are the RF exposure considerations at 100 watts up to full legal limits? Yeah, we just answered that one.
Again, I don't know. Like all antennas, they have RF exposure, and these little guys have more intense fields close to them.
Yeah. Montgomery asks, have you heard of anyone using Litz wire to build a portable loop? This would increase the efficiency compared to a stranded copper wire loop.
No, I haven't.
Yeah. I think this is another confusion between a magnetic loop and a full wave loop. Those are very different antennas, even though they're both in a loop configuration. You would never use wire to make a magnetic loop because the diameter is so small. I mean, that was one of the first slides that John showed. Using 14 gauge wire versus 1.5-inch diameter pipe. And the efficiencies that you get out of that. I think the Litz wire would help you in a full wave loop, but not these small magnetic transmitting loops.
Yeah, what Mark is saying is correct.
Yeah. All right. Jim, K4BSE asks, what is the polarization of the loop?
Depends how you set it. Set it up vertically, it's vertically polarized.
Is it? I thought they were horizontal if you've got it.
No.
Because it's like a slot loop. It's operating on the magnetic fields instead of the electric fields.
No, a vertical loop is vertically polarized.
Is it? Okay.
Yeah.
Okay. Steve W0TNT asks, can the aluminum tape be painted to make it more HOA friendly?
Of course. The coating of paint will have very little effect on it. The Krylon plastic paint, Fusion, I think is the name of it, is probably the ideal plastic paint, but almost any paint. Paint does not, a thin coating of ordinary spray paint or even ordinary emulsion house paint is pretty thin and will add very little dielectric constant to the environment.
Very good. Curtis, KT7CWD asks, what is your furthest DX with a mag loop?
I have not used the loop a lot myself. I've made local contacts with it. My buddies who have built it have been DXing all over the world, mostly in digital mode, and then it's all continents. So I can't claim much DX. I'm a builder more than a user. I build antennas, test them out to see that they work, and then go back to building something else.
Move on to the next project.
Yeah,
I can relate.
I've got a garage full of antennas, which I'm going to auction off at the next swap meet. But so if you want one of my project antennas.
But the important part, though, is that the other people who are making your loops are making all over the world kinds of contacts.
Oh yeah,
yeah. Actually, this goes back to the earlier question about the bandwidth of a fixed tuning capacitor. If you are really big into FT8, you can make one of these antennas and tune it for the FT8 or whatever digital area of the band you want to operate, and then fix it there, leave it there, and let it stay there. It's only going to be for that one band and for that one very narrow section of the band, but it will work gangbusters in that one particular situation, and you won't have to go outside and retune it or anything.
I'm surprised how many of the people who build them and then send me email or feedback and pictures are using them on the digital modes.
Yeah.
But it's a digital world.
It is. Alan, AK4F, asks, when calculating the conductor diameter ratio, is it any different for a multi-turn loop?
No. The conductor to loop size diameter ratio still works out pretty. Still has to do with the area of the loop, the magnetic area of the loop compared to the. That's a complicated question, but the answer is no. It's just to add turns. Don't worry about that. Still a 24-to-1 ratio.
Okay. So, Montgomery followed up on his question about the Litz wire. Should have an increased effective diameter since the surface area is larger compared to simple stranded wire. He was not referring to the full wave magnet or the full wave delta loop, but a mag loop.
Okay, that's fine.
But the Litz wire is still a very tiny diameter compared to 1.5-inch conductor or 1.5-inch pipe or 2-inch pipe. So
I don't see any problem if you could get Litz wire that the overall diameter of the wire was equal to the diameter of the pipe, then it worked fine. But I can't see any advantage to doing that.
Yeah. Oh, this is a good one. Keith, ZS6HI asks, the sliding conductor capacitor, must it be reasonably close fit, or what air gap is acceptable for the required capacitance?
They're not reasonably close fit, just because PVC pipes and so forth. That's one of the frustrations, I think, to so many inventive ham antenna builders, that none of the pipes, metal and plastic and so forth, that you buy at the hardware store, nothing fits anything else.
Yeah.
So pardon the slang, you make do with what you got.
Yep.
You go to the hardware store and you see what roughly fits inside of what, and then you build your antenna with it. Although I've got here's a little tip which maybe some of you have never found out, and I was happy as hell to find it. Pardon the slang. If you go to your local metals dealer, most bigger towns have a metals dealer. I don't mean your hardware store or your hobby store, but a metals dealer. The guy that sells big sheets of metal and big bars of iron and other stuff to the construction trade, a metals dealer. He sells steel and aluminum and maybe brass pipe and sheets of stuff to the construction trade. He sells both in aluminum pipe. He sells two types. He sells fractional tubing, and he sells pipe. Aluminum pipe and aluminum tubing are two different animals at the metals dealer. Aluminum pipe and aluminum tubing are different. Aluminum tubing is sized by outside diameter. Half-inch aluminum tubing is half an inch outside. Aluminum pipe is half-inch inside. It's scheduled pipe. Pipe is a scheduled size. So if you go down to your metals dealer and you buy a piece of half-inch schedule half-inch pipe, you're getting pipe that's exactly the same diameter inside and outside as the PVC pipe you buy at your hardware store. So if you want to buy some aluminum pipe that fits the PVC pipe you buy for building sprinklers at your hardware store, go to the metals dealer and buy not half-inch tubing, buy half-inch schedule aluminum pipe. It fits exactly into the PVC pipe you buy at the hardware store. I've built all sorts of antennas out of it, and you can fit them together just like they belong to each other. Don't buy aluminum tubing to go into PVC pipe. Buy Schedule 40 aluminum pipe. Anyway, that's a hint.
Awesome. We got one last question here before the top of the hour. Carl, KK4KRK, asks, I have a slightly off-topic question. John, do I recall correctly that you did a presentation on making a slot antenna from a discarded satellite TV antenna? It was probably several years ago.
Oh yes, definitely. That was my premier presentation,
Yep.
and I still give a presentation on that. If you want to see it, just contact me. I'll be glad to give it to your radio club. Just send me an email, and we'll gladly make that presentation. I still do it from time to time. W6NBC mail at gmail.com, and we'll gladly make that presentation.
That was your first article in QST that I ever read and said, holy cats, this guy lives in my town.
That's right.
Yeah, so
it was my premier presentation.
That's right. All right, we are at the top of the hour. Thank you very much, everybody, for attending. Thank you very much, John, for presenting.
My pleasure.
As always, wonderful material, and thank you for all your wonderful questions. This video will be available on the QSO Today Ham Expo webpage for 30 days after this weekend. And yeah, thank you all very much, and I hope you have a wonderful rest of the expo. Cheers. 73.